Hi dear friends, the last part of the vector addition deals with the rectangular vector components in three dimensions. So 3D means three dimensions, rectangular vector component. Let's talk about it now. So for this purpose, we need a coordinate system, that is a Cartesian coordinate system or rectangular coordinate system. The x-axis, y-axis, z-axis. This is the origin. Let us take this vector quantity, let it be any vector A. We need to calculate its component along x-axis, its component along y and z-axis. So we need the vector components or the component of this vector along x, y and z-axis. So how to do that? For this purpose, the vector OP, it will be A. We need the component of A along x direction, along y direction, along z direction. Therefore, we need to draw the perpendicular from the tip of this vector onto the xz plane. This is the xz plane. Let it intersect the xz plane at this point. Let it be M. Now we can say that OM is the vector component of the vector A in xz plane. So OM is the component of the given vector along or in xz plane. The component of A vector in xz plane. But we need the component of the vector A along x, y and z direction. For this purpose, again we need two sets of perpendicular. Already we have dropped one perpendicular. That is Pn on xz plane. Now we have to draw another two sets of perpendiculars from the tip of this vector OM onto x-axis, onto z-axis, and of course we need another perpendicular from the tip of the given vector onto y-axis. Let the perpendiculars, this one, this one, and this one, meet the x-axis at the point say N, Q and R. Now we can write this segment ON as the component of A along x-axis and OQ as the component of A along z-axis, and this is the component of A along y-axis. the component of A along x-axis, y-axis and z-axis. Since x, ay and az are the components of the given vector A along x, y and z axis respectively, we can write the vector resultant, the vector combination or the vector addition of these three as the given vector. So these are the components of the given vector, and the addition of all these vectors components is equal to the given vector. So given vector A is the addition of the resultant of these three vector components along x, y and z axis. So this is the x, this is ay, this is x, this is ay, and this is az. So x plus ay plus az is equal to a. We can write x as x vector as its magnitude times its unit vector. I is the unit vector along x-axis. Already we have discussed about the unit vector. I cap is the unit vector along x-axis and z cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. In this way, we can write x vector is equal to its magnitude into the unit vector along x-axis, ay as the ay vector as the magnitude into its unit vector along y-axis, az can be written as its magnitude times the unit vector along z-axis. So in this way, the given vector can be written in this way. So rectangular vector components in 3 dimensions. This is a rectangle, this is a rectangle. Of course, you can find so many rectangles. So rectangle means always the axes are mutually perpendicular. Therefore, it's called rectangular coordinate system. Cartesian coordinate system can be called rectangular coordinate system. A rectangular coordinate system, the component of the vector given vector A like x, y and z axis can be written in this way. I repeat how to find the component of a given vector along x, y and z axis. First of all, we should keep the tail of this vector at the horizon, then drop a perpendicular from the tip of the vector onto the xz plane. Of course, you can choose yz or xy plane, doesn't matter. But I have chosen the xz plane. I dropped a perpendicular onto xz plane and it meet or intersect the xz plane at the front end. Therefore, this segment or the vector OM is the component of the given vector in xz plane. Again, you drop two sets of perpendiculars onto x and z axis, and the resulting segments OM and OQ of this component of this vector on or in xz plane. Component of this vector, its component, that is x and z along x and z axis respectively, and dropping another one perpendicular on y axis, we can get the y component directly. So in this way, we can get the component of the vector along the three axes. So x, ay, and az are the components of the vector A. Therefore, vector A is the resultant of these three vectors, or the addition of these three vectors, or the vector sum of these three vectors. So we can recast the expression. Vector A is equal to x plus ay plus az. This can be written as xi cap plus ay z cap plus az cap. This is the magnitude, this is the direction. Once unit vector, magnitude and direction along x, y, and z axis. This is given vector. Now we have to calculate its magnitude, and I need to calculate the unit vector of the given vector A. How to calculate the unit vector is given as A cap. That's equal to the given vector or its magnitude. So how to find its magnitude? It's quite simple. There is the magnitude or length of the given vector A. If the rectangular components of the given vectors, if the rectangular component of the given vector x, ay, and az are known, its magnitude can be calculated as x square plus ay square plus az square root of this. This is the magnitude. But how to prove? Proof is very simple. You know that x square plus az square is equal to square of this vector. So I can write A vector can be written as vector A can be written as vector OP. So in this right angle triangle, O and P, OP can be written as OM square plus PM square root. Can be written as OM square plus PM square root of this. But we can have this triangle, we can take this triangle. in this triangle. In this triangle, we can write OM square is equal to OQ square plus, because this is perpendicular. This is the hypotenuse in this right angle triangle. So OM square is equal to OQ square plus OM square. So I substitute OM square here to get the desired result. So A is equal to the magnitude of the given vector. A is equal to OP is equal to, instead of OM square we can write OQ square plus OM square and plus PM square. OQ is the AZ, Z component of the given vector. OM is the X component of the given vector, and PM, this vector is equal to this vector. This length is equal to this length. So PM is equal to OP. So that's OP is equal to AY. So AY square. Hence proved AX square plus AY square plus AZ square. So we can write, rearrange the terms, AY square plus X square plus AY square plus AZ square square root of this. So A can be written as this: X square plus AY square plus AZ square square root of this. That's equal to the magnitude of the given vector. Hence proved. Let me take a small example for you. The example is how to find the given vector of a vector A is equal to I cap plus Z cap 2 J cap plus 3 K cap, suppose. So how to find it? As we have little ago, we have found a relation, found a formula of the unit vector of any vector as a vector upon its magnitude. Here, the magnitude of the given vector is given by the formula x square plus ay square plus az square, square root of this. Put what is x? This is x. What is ay? This is ay. What is az? This is az. So put x is equal to 1, ay is equal to 2, and az is equal to 3. To obtain the unit vector, as the given vector is I cap plus 2j cap plus 3k cap upon x square, this is 1 square, plus ay square, this is 2 square, plus az square, this is 3 square. So next step, we are getting I cap plus 2 j cap plus 3 k cap upon 1 square is 1, 2 square is 4, 4 plus 1 is 5, 3 square is 9, 9 plus 5 is 14, root 14. This is the answer. 9 plus 4, 13, plus 1, 14 square root of this. So this is the unit vector of the given vector. After learning the vector component method, by using the vector component method, we can find the component of a given vector. Using this vector component method, we can add more than 2 vectors at a time. How is it possible? If 3 vectors are given, then we can find the component of each vector along x, along y, and along z direction respectively. And then we can add all these vectors. In this way, we have to add x component of one vector with the x component of the second vector with the x component of the third vector, and so on. Similarly, y components, z components can also be added to get a resulting y, x and z component of the resulting vector. So this can be cleared by taking a suitable example. Let me take an example of say 2 vectors. Find the resultant of the vectors A is equal to I cap minus j cap and B I cap plus j cap. So how to solve? Let the resultant of these 2 vectors in V, B, C. Then secant written vector A, that is 2I cap minus j cap plus vector V. V is given as I cap plus j cap. So we can add x component of vector A with the x component of the vector V. So 2I cap plus I cap plus y component of the vector A, that is minus j cap, plus y component of the vector B, that is j cap. In this way, plus j cap minus j cap will get cancelled. So we are getting 3I cap. I will show the result of these 2 vectors A and B as the vector C in a diagram. That is called the vector diagram. We have got 3I cap. This is vector A, 2I cap, 2 units along positive x direction and 1 unit along negative y direction. Minus j cap is the direction. J cap, this is j cap direction, this is minus j cap direction, this is the I cap direction, this is minus I cap direction. So this is A. This x component is 2, y component is 1, negative y direction. And B vector, x component is 1, y component also is 1, 1, 1. This is the B vector. So when you add these 2 vectors, this y component of B vector is cancelled by the y component of a vector. Ay and by they get cancelled. So we are having the resultant of these two vectors along x direction. That's what we obtain. We can show it in the given diagram. These two vectors, if you add these two vectors also, we are getting a parallelogram and the relative vector will be a 10 along x direction because y component of both the vectors will get cancelled. So this is the resultant of these two vectors. This is the vector C. 1, 2 and 3. So the magnitude of vector C is 3 and direction is along positive x-axis. Let's start with the mathematical part. Vector R is equal to the resultant of these four vectors. Vector R is the resultant of the four vectors A, B, C, D. A vector plus B vector plus C vector plus D vector. We got the given vectors in terms of I cap and j cap. Vector A is given as 4 I cap plus 3 j cap. This is vector A, and vector B is minus 3 I cap plus 3 root 3 j cap, and vector C is given as minus 2 I cap minus 2 root 3 j cap, and vector D is equal to 2 I cap minus 2 j cap. Now we have to add I cap with I cap, j cap with j cap. Take I cap common, then take j cap common. 4 plus minus 3 plus minus 2 plus 2. So we can just write 4 I cap minus 3 I cap. I cap we have taken common. 4 minus 3. Then this is I cap we have taken common minus 2. Here I cap we have taken common. This will be minus plus 2. Now we are going for j cap. Here this is 3 j cap. Here 3 root 3 j cap. Here minus 2 root 3 j cap. Here minus 2 j cap. Take j cap common. Here 3, sorry, here minus 3. Oh yeah, it's correct. Here plus 3. Here 3 root 3. Here minus 2 root 3. And here minus 2. So 2 to getting cancelled. 4 minus 3 is 1, that is I cap, plus 3 minus 2 is 1, and 3 root 3 minus 2 root 3 is just root 3. So it is just root 3 plus 1 j cap. So this is the resultant vector R. So the coefficient of I cap is 1. This is the x component of the resultant Rx, that is 1. This is the coefficient of j cap, this is the resultant R is y component, so Ry is root 3 plus 1. Both are positive, therefore the resultant will be definitely lying in xy plane, positive xy plane. This is y plane, this is y axis, this is x axis. Rx is 1 and this is root 3 plus 1, so it will be between 2 and 3. Between 2 and 3, somewhere here. So the resulting will be like this. The resultant vector is R. The x component is 1 and the y component is root 3 plus 1. The resultant will be like this. This is the resultant, R vector. Can just write here, you see, R vector like this. And that's the magnitude we can calculate. Rx square plus R square root, and this is equal to 1 square plus root 3 plus 1 square root of this. This is equal to 3 plus 1, 4 plus 1, 5 plus 2 root 3. Square root of this. This is the magnitude of the resultant, and its direction can also be calculated. Let it make an angle phi with respect to positive x direction. So we have to find its direction also. Phi equal to tan inverse or we can write tan phi is equal to, this is the Ry, this is the Rs. So tan phi is equal to, in this right angle triangle, tan phi is equal to this upon this. This is Ry and this is Rx. So tan phi is equal to, what is Ry? Root 3 plus 1. What is Rx? 1. So phi can be given as tan inverse root 3 plus 1. So this is the direction part of the resultant and this is the magnitude part of the resultant. So as a whole, this is the answer. So resultant can be given as I cap plus root 3 plus 1 j cap. It is the magnitude of the resultant, 5 plus 2 root 3 square root of this quantity, and this is the direction, tan inverse root 3 plus 1 with respect to positive x direction. The resultant vector is oriented or pointed. So when the angles are given of so many vectors, more than 2 vectors, we have to find each vector in rectangular components, a rectangular coordinate system by using rectangular component method or vector component method and rectangular coordinate system. Each vector can be written in that way and add all these vectors I cap with I cap, j cap with j cap and k cap with k cap to get the resulting vector. And if it is in the y plane, then we can find the resultant by using the formula x square plus ay square Rx square plus Ry square root. Rx square plus Ry square root is the resulting vector's magnitude, and the time inverse Ry upon Rx, that is the angle made by the resultant vector with respect to positive x direct. That's quite simple.